One thing I wondered about, since I'm more familiar with the Altair 8800, that is, it has no programmed output LEDs. I know that it has the ability to read the upper 8 address switches as a programmable input, and that's frequently used by software and operating systems and so on to get information from the user. But the IMSAI has these extra 8 LEDs, and they're just called programmed output. The maker of this kit says nothing about them that I've been able to find, and I've sent a couple inquiries about it which have not been responded to so far. I was trying to study up on how that actually worked internally, because I had never messed with the 8080 in regards to direct access to I/O. Now the 8080 was not intended to be memory mapped I/O like more modern processors often do. It treated I/O as a totally separate hardware thing, and it allows for 256 inputs and 256 outputs. So they're numbered 0 through 255, or 0 through FF in hexadecimal. So you have that many for inputs, that many for outputs. And the status LEDs on the front panel of both the Altair and the IMSAI, those are brought out of the 8080 in a sort of a sneaky way when a particular combination of the 8080's control pins are in a particular combination at a particular point in the machine cycle. That indicates to external circuitry that the 8 bits of status that are internal to the 8080 are output on the data bus. So, through the use of an 8-bit latch, it's possible to grab onto those 8 bits of status when they're briefly put on the data bus, and then use that however you want to use it. One way they're used is to illuminate these 8 LEDs in the status area. Another way of doing it is that 2 of those status bits, for example the INP or input and the out, those are the things that indicate to external circuitry that the 8080 processor is executing an I/O command, in other words an input command or an output command. In that situation, when one of those bits is on, input or output, that means that temporarily, briefly in the machine cycle, the address and data buses do not have the normal stuff on them that would be used to interface with memory. Instead, it's expecting to interface with the input-output circuitry. So it's a fairly simple thing to then grab the data on the data bus and look at what's on the address bus. And I actually think it's the upper 8 bits of the address bus, but I'm not positive. It may be both. I've read that both the upper and the lower 8 bits of the address bus have the same pattern put on them, and that's the number in hexadecimal between 0 and FF. That's the I/O address. Regardless, that is brought out, and then external circuitry can say, oh, it's trying to input data from I/O device such and such, and it can react accordingly, or the same thing for an output. So in fact, that's how these 8 switches are brought in. An input using input address FF is causing these switches to do double duty and be read by the 8080 in that situation. So I surmise that maybe these 8 programmed output LEDs might operate off the same address, so an output command specifying output address FF might control those. So I wrote a simple program. It just reads in these as input and then immediately copies those bits to the same address output. And I remembered reading somewhere where they were technically inverted the way they were hooked up. So I'm running this program now, and all the switches are down and all the LEDs are on, But if I raise a switch, its corresponding LED turns off. So that's the answer to that question. Now I know how to control these if I ever want to in the future. That's sort of a hidden feature that doesn't seem to be well documented, so I'm glad I figured it out. I was searching online trying to find it, and nobody seemed to be mentioning it, so maybe I've done a small service here.